The year is 1829. Picture a time before cars, before planes, even before proper roads. Imagine a world where the fastest way to travel was by horse-drawn carriage, and the idea of crossing vast distances in a matter of hours was nothing more than a dream. This was a world on the cusp of a technological revolution, and at its heart chugged a machine called the rocket. This steam locomotive was not just a marvel of engineering, but a symbol of the dawn of a new era. This wasn't a spaceship, mind you, but something just as groundbreaking. A steam locomotive that would redefine transportation and usher in the age of railways. The rocket was a harbinger of change, a machine that promised to shrink the world and bring people closer together. The rocket wasn't the first steam locomotive, not by a long shot. Steam engines had been around for a while, but they were often slow, cumbersome, and inefficient. But it was the most important. The rocket was a game changer, a locomotive that set new standards for speed, power, and efficiency. Why? Because it combined several innovations in a way that had never been done before, resulting in a machine that was faster, more powerful, and more efficient than anything the world had ever seen. It featured a multi-tubular boiler, which allowed for better heat exchange and more efficient steam production. It captured the imagination of the public and proved, without a shadow of a doubt, that steam was the future of land transportation. People gathered in awe to watch this mechanical marvel in action, their minds racing with the possibilities it represented. This groundbreaking locomotive was the brainchild of George Stephenson, a self-taught engineer with a head full of steam, pun very much intended, and a vision for a world connected by iron rails. Stephenson's journey from humble beginnings to becoming a pioneering engineer is a testament to his ingenuity and determination. The rocket's triumph at the Rainhill Trials, a competition held in 1829 to find the best new locomotive design, cemented Stephenson's place in history and set the stage for a global railway boom. The Rainhill Trials were a pivotal moment, showcasing the rocket's superior design and performance, and convincing skeptics that the future of transportation lay on iron rails. Following the success of the rocket, railways began to spread like wildfire across the globe. Tracks were laid down, connecting cities and towns, and transforming the way people and goods moved. The world was becoming smaller, more connected, and more dynamic, all thanks to the humble steam locomotive. Today we have high-speed trains that can travel hundreds of miles per hour, but it all started with the rocket. This pioneering locomotive set the wheels in motion for the incredible advancements in rail technology that we see today. The legacy of the rocket lives on, reminding us of a time when steam and steel changed the world forever. To truly grasp the significance of the rocket, we need to rewind the clock and understand the state of transportation in the early 19th century. Imagine a world where journeys were long, arduous, and often dangerous. Roads, mostly dirt tracks, were treacherous and barely passable for horse-drawn carriages, especially after rain. Rivers and canals offered a more efficient alternative, but they were limited by geography and prone to freezing in winter. The Industrial Revolution was in full swing, and there was a growing need to move goods and people faster and more efficiently. Something had to change. Early attempts at steam-powered transportation had been met with limited success. These contraptions were often slow, unreliable, and prone to breakdowns. They were also heavy, damaging the very tracks they ran on. What the world needed was a breakthrough, a leap forward in locomotive design. Enter George Stephenson and his rocket. George Stephenson, born in 1781 to a humble family in England, was a man of remarkable ingenuity and determination. Despite his modest beginnings, Stephenson's relentless curiosity and passion for mechanics set him on a path to greatness. He had a natural aptitude for mechanics, honed through years of working with machinery in coal mines. These early experiences were crucial in shaping his understanding of mechanical systems and problem-solving skills. Stephenson taught himself to read and write in his spare time, devouring any book on engineering he could get his hands on. His thirst for knowledge was insatiable, and he often stayed up late into the night, studying and experimenting with new ideas. His fascination with steam engines led him to design and build his first locomotive, the Blücher, in 1814. This early creation was a testament to his innovative spirit and mechanical prowess. While the Blucher was a significant achievement, Stephenson knew he could do better. He was never one to rest on his laurels and was constantly seeking ways to improve his designs. He continued to refine his designs, incorporating new ideas and innovations. His relentless pursuit of perfection led to numerous advancements in steam engine technology. The Rainhill trials, announced in 1829 by the Liverpool and Manchester Railway, presented the perfect opportunity for Stephenson to showcase his latest masterpiece, the rocket. This event was a pivotal moment in the history of railway engineering. This competition, held over several days, pitted the rocket against other leading locomotive designs of the day. The atmosphere was electric, with spectators eagerly watching the trials unfold. The challenge was simple: to determine the most reliable and powerful locomotive capable of hauling a heavy load over a set distance. The rocket's performance was nothing short of spectacular, demonstrating Stephenson's genius and solidifying his place in history as a pioneer of railway engineering. The rocket not only won the competition, but also set new standards for locomotive design. Its success marked the beginning of a new era in transportation, revolutionizing the way people and goods moved across the country. Stephenson's legacy lives on today, as modern high-speed trains and advanced railway systems owe much to his groundbreaking work. His contributions laid the foundation for the development of the global railway network, transforming the world in ways he could never have imagined. George Stephenson's story is a testament to the power of perseverance, innovation, and the human spirit. His journey from a humble background to becoming one of the most influential figures in engineering history continues to inspire generations of inventors and engineers. The rocket, though simple by today's standards, was a marvel of 19th century engineering. It was a pioneering machine that set the stage for the future of rail transport, showcasing the ingenuity and ambition of its creators. Let's take a peek under the hood, or rather behind the boiler, to understand what made it tick. The rocket was not just a locomotive, it was a symbol of the Industrial Revolution, embodying the spirit of innovation and progress. At its heart was a revolutionary multi-tubular boiler. This design was a significant departure from the single-tube boilers that had been used previously, representing a leap forward in engineering. Unlike previous designs that used a single fire tube, the rocket's boiler contained 25 copper tubes. These tubes were crucial in increasing the surface area for heat exchange, making the boiler much more efficient. These tubes carried hot gases from the firebox through the water tank, heating the water more efficiently and generating more steam. This innovation allowed the rocket to produce more power without requiring a larger boiler. Speaking of the firebox, it was separate from the boiler and had its own door for feeding coal, allowing for a hotter, more intense fire. This separation was a key design feature that improved the overall efficiency and safety of the locomotive. Now, onto the business end of the rocket, the cylinders and pistons. These components were the workhorses of the locomotive, converting steam power into mechanical motion. The rocket had two cylinders, one on each side, positioned at an angle. This angled arrangement was innovative, as it allowed for a more balanced and efficient transfer of power to the wheels. Steam from the boiler pushed the pistons back and forth, turning the wheels via a connecting rod and crank mechanism. This mechanism was a marvel of mechanical engineering, translating the linear motion of the pistons into the rotational motion needed to drive the wheels. This arrangement provided more power and smoother operation than previous single-cylinder designs. The use of two cylinders meant that the locomotive could maintain a more consistent speed and handle heavier loads. Finally, we come to the blast pipe, a deceptively simple but ingenious invention. This component played a crucial role in the rocket's performance, enhancing both its power and efficiency. This pipe, positioned at the base of the chimney, channeled exhaust steam from the cylinders upwards. By doing so, it created a draft that pulled more air into the firebox, intensifying the fire and increasing the production of steam. This created a vacuum in the firebox, drawing in more air and intensifying the fire. The increased airflow allowed the fire to burn hotter and more efficiently, which in turn produced more steam and more power. This clever system significantly increased the rocket's power output and efficiency. The combination of these innovative features made the rocket a groundbreaking machine, setting new standards for locomotive design and performance. It was a true testament to the power of human ingenuity and the relentless pursuit of progress.